Let's see how to configure load cases in CYPE Connect. To do this, once the node has been created, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. In the connection pop-up window, if the model of the connection is already complete, we go to the Analysis tab. Then, we click on the Load Cases option in the top toolbar. In the pop-up window, we define the load cases for the connection analysis. We may have generated these load cases automatically using Generate from the BIM model. We can also modify them or enter them manually. In that case, we use the buttons at the top of the table, which allow us to add, copy, delete, and move load cases in the list. We define the following parameters for each load case. First, we type in its reference. Next, we mark whether or not it is acting by checking the corresponding box. On the right, we find configuration parameters for the nonlinear connection analysis carried out by the program using the OpenC's engine. Material nonlinearity, geometric nonlinearity, and contact nonlinearity can cause changes in the stiffness matrix. Therefore, the analysis process is both incremental and iterative. The loads applied in each load case are divided by the indicated number of load steps and applied incrementally in each load step until 100% of the loads are reached. For example, if we apply a load of 100 kilonewtons and define 5 steps, each load step will add another 20 kilonewtons until we reach 100. The values in the following columns, tolerance and iterations, are associated with each load step. We must type in the allowed tolerance to consider that the convergence has been reached. The convergence criterion used to terminate the iterative process for each load step is the error in terms of energy. When the energy variation between one iteration and the previous one is less than the defined tolerance, the program considers that the equilibrium state is reached in the load step and proceeds to the next one. We also state the maximum number of iterations to be carried out in each load step. If the equilibrium is not reached in an individual step within the maximum number of iterations entered, the analysis is restarted by doubling the number of load steps. If the equilibrium is still not reached, this process will be repeated again, being interrupted if the maximum number of reattempts entered in the rightmost column is reached. The default values are considered optimal in order to obtain satisfactory results in a reasonable analysis time. Finally, if timber sections are involved in the connection, we also select the situation and duration of each load case in the corresponding drop-down menus.